Welcome to our YouTube channel Fusion Tech. Today we are back with a new video. So we are going to learn about what is voltage and current. So please do like, share and subscribe. Also don't forget to hit that bell icon to get the latest updates about our upcoming videos. So before going into the actual details about what is voltage and current, first we will start with the atomic structure. The atomic structure consists of two parts, namely the nucleus and the orbits. As you can see here, the nucleus consists of the protons, which are positively charged, and the neutrons, which are chargeless or they don't carry any charge, and the electrons, which are negatively charged, which are revolving around the nucleus in circular fashion, also called as the orbit. Now we will go into understanding what is voltage and current. First, we will see the definition of the voltage and then we will see about current. Now, the voltage is difference in the electric potential between two points. Now, to understand this, we will take one example of a battery or a cell. So, you might have seen this cell in a remote controls or some toys. This is having two terminals, positive negative terminal. So this positive terminal is at a higher potential and the negative terminal is at a lower potential. If we take the difference between the potential of these two terminals, then we can monitor what is the voltage of this cell. The unit for measurement of voltage is volt. Voltage is also called as the electromotive force, that is EMF, or it is also known as the potential difference. So in upcoming slides, we will go into the deep about the concept of potential difference. Now we will see what is current. Now the current is nothing but the flow of electrical charge carriers, also called as the flow of electron. Now consider there are 2 points, point A and point B, and there is one conductor of electricity from point A to point B. Now if we apply a voltage source across this conductor, then there will be a flow of charges. So let's suppose Q amount of charge is flowing from point A to point B in T amount of time. We can calculate the current with the help of this expression. So current will be equals to the charge denoted by the letter Q per unit time. Okay, the unit for current is ampere. So let's suppose a 1 coulomb of charge is passed through a conductor for 1 second of time, then the resultant current will be 1 ampere. Now as you have understood the basic definitions of voltage and current, we will see some practical examples to understand the concepts of voltage and current. Now consider here we have taken one copper wire which will have a lot of electrons. As per the atomic structure we have seen, there are some electrons. Now what voltage is doing is, as you can see, the voltage is pushing these electrons so that these electrons will start flowing from one terminal to other terminal, which will ultimately result into flow of electrical charge carriers or flow of electrons, which is nothing but the current flow. So now from here you can understand that the voltage is the push which is given in order to start the flow of current. So we'll understand the concept of potential difference with one more example. So suppose we have two tanks, tank 1 and tank 2. Tank 1 is completely filled with water, tank 2 is completely empty. And these two tanks have been connected with the help of a passage. As you can see here, this passage. And the passage is controlled with the help of a switch. As you can see, the switch is in closed state. So the passage is completely blocked. So no water can enter from tank 1 to tank 2. Now, in the next step, we open this switch. So once the switch is open, the water from tank 1 will start depositing in tank 2. This is because the tank 1 water level is at higher potential and the tank 2 was completely empty, so it was at lower potential. So the water will start to deposit in tank 2 as long as the levels of these two tanks becomes equal. So as you can see in the next image, now as you can see here, the tank 1 and the tank 2 reached almost the same water level, is almost zero. Once the water level difference becomes zero, the flow of water current also will going to reduce. Now same way we will take this analogy to understand the electrical circuit. Here you can see there is one battery which is having two terminals. So consider positive terminal as a tank 1 and negative terminal as tank 2. Now for connecting these two tanks we used one passage. So here we are using one conductor which is connecting these two terminals together, and as this is a switch we used for allowing the water flow from tank 1 to tank 2, we are going to use one switch here. As here we were easily able to visualize, or we can see the flow of water, but we cannot see the flow of charge carriers or the electrons with our eyes. So what we have done is we have connected one load or a lamp here to visualize the flow of electrical charge carriers, also called as the electrons. Now when we will close this switch, what will happen is there will be a flow of charge carrier. As you can see in this example, once the switch is closed, flow of electrons started and the lamp is getting illuminated. From this example, it is pretty clear that the current will start to flow once there is a potential difference in the circuit. Your terminal 1 is at a higher potential and terminal 2 is at a lower potential. So there will be a flow of current which will ultimately cause the current to flow in your circuit. These are all these examples where we have seen ratings in terms of voltage. So hey guys, this was all about today's video. I hope this video will be useful for you. So please do like, share and subscribe to my channel. Also don't forget to hit the bell icon to get the latest updates and notifications about my upcoming videos. So thank you again.